Hey everyone, welcome back to another Leetcode daily video. Today we're going to be solving 1457 pseudo-palindromic paths in a binary tree. So this is a medium problem. Given a binary tree where node values are digits from 1 to 9, a path in the binary tree is said to be pseudo-palindromic if at least one permutation of the node values in the path is a palindrome. Return the number of pseudo-palindromic paths going from the root node to leaf nodes. Here's an example. So 2, 3, 3. This would be the arrangement would be 3, 2, 3. And then here the arrangement would be 1, 2, 1. So if we just continue here would be 1, 2, 1 again. So if a keen observation would be that for it to be a pseudo-palindromic, it would have to have at most one uh non like one odd frequency uh digit. For example, if you see here 2 and 1, the frequencies of 2 and 1 are odd, so that won't work. Here 2, 1, 3, 1, the frequencies of 2 and 3 are odd, so they wouldn't work either. So I'm pretty sure you guys can tell if you've watched my previous videos. This is going to be a DFS video. And if you've watched my previous videos, you would know that I would just initialize the empty array. The first index would be 0 since we have no paths. We would go ahead and initialize the depth first search. So let's go ahead, def DFS. And so what we would pass in is the root, as always, and the path. So the path is going to be a set of all the numbers we've seen. So like normal, if not root, return, right? So this is not where we're gonna do our checking, because this is past the leaf node. Oh my god. Okay, so now let's go ahead and find the leaf node. So if not root dot left and not root dot right. So if we're at 3, there's no left and there's no right. If we're at 1, there's no left, there's no right. So that means that we're at a leaf node, right? So now what we have to check is if root dot val, we would have to add it one more time to the set. So this number itself in path. So if it's already in there, we would remove it. So we would do path dot remove root dot val, right? So in the end, what we want to check is that the length of the set is equal to or less than 1. That means that we only have one odd occurring value. So if it was in the path, it would get removed, and so if it wasn't, then we would add it, right? So we would do else path dot add root dot value, right? So this is going to be the last time we're doing this in the leaf node to add like the value of the leaf node itself. And then here at the end we would check if len, so if the length of the path is less than or equal to 1, right? So that means that it's correct, and we would do count at index 0 plus equal 1. Okay, so now what if it's not in the leaf node, right? So we would still add it, right? So let's go ahead and just copy this down here. Indents might be an issue. Okay. Okay, so we still have to add it, right? Now, after all of this, we just have to do the recursion. So we'll just go root dot left, and then here we have to do a hard copy of the set We just do this. I mean, you could also do dot copy, I'm pretty sure. So we're just going down the left and then the right. And then so after all of this, all we have to do is we have to call this. So we would do dfs root set, and then we would send in an empty set, and then we would return count index 1. You could also do the non-local, but I don't know. I feel like this would be more efficient. Let's go ahead and run it. Okay, let's go ahead and submit. Okay, and it's decently fast. The thing with Leetcode is that these don't really mean anything. Like if we look at this is probably the same. Okay, yeah, I guess they did it iteratively with bit masking. So here's the solution for that. Bit masking is basically the same thing we're doing, but since there's only 9 numbers, right, in from like 9, 0, 1, 2, 3, 4, 5, 6, 7, 8. Wait, 9. Oh, it's 10. So there's only 10 numbers, right? So at most, you would have to, yeah, just do 9, right? I mean 10. So what they do is, for example, if they see a 0, the first time they would flip it to 1, the second time to 0, and so on. So they would get like the odd and even, yeah. All right. Well, that's it for today. Make sure to like and subscribe. Connect with me on LinkedIn, and I'll see you guys tomorrow.